In this lesson, I will show you some basic attributes of TensorFlow Keras sequential models. Let's go ahead and get started. There are two types of attributes that I want to show you. The first type is the attributes of layers, and the second type is the attributes of input and output. Let's go through them one by one. Layers are the basic building block of neural network. Layer consists of two things: the tensor in, tensor out computational functions, and state. The computational functions is actually performed by a logic defined to each of the layers. The logic is applied to the input tensor and help us to return the output tensor. And then for the state, which represent the weight of each of the layer and is updated during the training and is stored with it. Let's take a look on the example. Let's import the sequential models, the dense layer, and also activations layer, and then create these models by using the act functions methods. And this is the model that we have. We have, just like here, we have 3 inputs, 2 neurons in the first layer, and then 1 neuron in the second layers, with the sigmoid functions in the last as the output. A layer instance is callable, much like a function. It will return you a list containing the following informations that includes the names and also that includes the address. Now let's call out these functions to see what we got. Just like what I mentioned, these dot layers functions will return you a list. You can see that it will return you a list of each of the layers that we have, because we have 2 layers, so it will return you 2 elements inside this list. And then in each of the elements here, it will let you know what types of layers that you are using, and also provide you the layer's address. And because this is a list, it will return. Indexing is allowable, so we can use the index to get each of the item inside this list. And you can see we can just use the model dot layers and then find out the first element, and then find out the second element. And also there's a functions from these one. We can call out the name from the first item, or call out the name from the second item. And this name is the dense 8, and this name is the dense 9. And if I refer it back to these models, you can see it will return me the same name as from this sequential model. Layer can be renamed by adding an argument in each of the layer. While you are doing the add functions, you can actually put a name over there. This is a name for the first layer, and this is the name for the second layer. And then if I repeat, I just build the functions again. This is the name. Now, instead of dense 8 or dense 9, now it's called the first layer and second layer. Again, we can use the functions to call it. And you can see the name has been changed to first layer and second layer. Layers can also be retrieved with the use of getLayers functions. And we can use the index to retrieve the layer, or we can use the name to retrieve the layer. Let's take a look on this example. We can use index, that is the first layer I want to have. We use the dot get layers functions and provide the index equals to 0 to get the first layer. Or we can just change the parameters to equals to name equals to first layer, or just simply put a first layer here, and it will return us the first layer. This is particularly useful when we want to investigate a particular layer. On the other hand, let's take a look on the attributes of inputs and outputs. Sequential model groups the layers into an object for training. Besides hidden layer, there are two specific layers. That is the inputs layers and also an outputs layer. The inputs layer serves as an entry point to a neural network, and then the outputs layer serves as an exit point of the neural network. And they are both callable by the .inputs and .output function. Let's take a look on the following example. If I use the .input functions, it will call you the inputs layer. If I use the .output function, it will call you the outputs layer. Let's run this cell. You can see there are few parameters returned from these lists. There are some things inside this list. Let me go through it one by one. First of all, you will note what kind of objects that it is. This is a tensor. This is a tensor object, so because this is a input, so this is a tensor input. And then for this one, because this is an output, so this is a tensor output. You will know the name. It will return you a name. This is the first layer, and this is the second layer. It will also return you the shape. This is the shape that you have for the input, and this is the shapes that you had for the output. Say, for example, the batch size is non-typed. That means it is not defined at this point, and it can accept any batch size. And you have 3 inputs, and then for the output, you have 1 output. In addition, in the output functions, you will note the activation functions. That is a sigmoid activation function. Remember that so far we are using the .add methods to incrementally set up the layer, starting from the first layer. There is also a corresponding .pop method to remove the layers, starting from the last layer. Let's take a look to see how we can use this function. Let's print out the length of the layers that we have so far. We have 2 layers. And then if we use the .pop functions, remember that it will remove the layers starting from the last layer. That means it will remove my very last layers right here. Let me show you. This is the second layer is going to remove. Now, if I use these functions and print out the number of layers, it will return you 1 because the last layer has been just removed. And now if I add it back by using the .add methods, it will return me the additional layer or the layers that it has been just removed. In this video, we have just gone through the attributes of layers and the attributes of input and output layers. In the next video, I will show you how to save and load a trained neural network. This is extremely important. See you in the next video. Bye-bye.